Pleasant good day. Welcome to Algebra 1 tutorial. I'm Teacher Olton. So today we're going to look at some algebra, including simplifying algebraic expressions, linear and simultaneous equations, and factorization. Before we get into this, let's just appreciate what God's word says. Now the Lord of peace himself give you peace always by all means. The Lord be with you all. According to 2 Thessalonians 3:16. So may the peace of God be upon you in spite of what you are going through. Continue to trust in the Lord and hold on. He will make a way. So question number 1. Simplify the following. So we need to remove the brackets here. And when we do that, we'll notice 3 multiplied by 2n plus 2n minus 5. This will equal to minus 4n plus 6n minus 15. So we simplify like terms, minus 4 plus 6. That will give us plus 2n minus 15, which is the answer for this one. So in the part 2 of the question, the LCM here will be 2x multiplied by x minus 3. Then we divide this whole expression in the denominator by first by 2x, which will give us the x minus 3. Of course, we multiply 4 by that, so it will be 4 by x minus 3. And then we divide the denominator by x minus 3, which will give us 2x. So let me just show you what's happening when I say divided by the x minus 3. Notice in this case, this will cancel with this. We are left with 2x. And this 2x is multiplied by minus 5. Right, so this could simplify quite nicely here to give us 4x minus 12 minus 10x all over 2x by x minus 3. So we can further simplify 4x minus 10x to give us minus 6x minus 12 divided by 2x multiplied by x minus 3. Now, if you wish, you can even take this further. So let's say we can factor out 6. Yes. This will give us 6 into minus x minus 2 all over 2x into x minus 3. Right, so the reason why I took out 600 minus x minus 6, simply because we don't want to get too tied up with the minus sign. We'll do it the other way as well, and I'll show you. So this will give you 3 multiplied by that. So you can leave it as that, or you can write it as minus 3x minus 6 all over x into x minus 3. Now, what you cannot do in simplifying these type of problems, you cannot cancel this minus 3 with this minus 3 here and say it's something like 1. No, the only how you cancel, and that's why I decided to show you this way, is if you make use of brackets and you factorize as we did here with the numerator right here. And then after factorizing, then you can cancel, okay? All right, so let's go to, all right, so let me just show you if you are taking out minus 6, you would have been left with x plus 2, right? Because when you multiply out these, you will get minus 6x, which is this piece here. And then minus 6 by plus 2 will give you minus 12, which is this piece here, right? So be careful to change your sign. You could not have written back a minus here because that would have given you a plus when you remove the brackets. Okay, and then of course you do the same thing which we just did. It is only when you factorize, then you can consider dividing, right, by this 2 here. So this will give you 3. And of course, you could leave your final answer as minus 3 into x plus 2, all divided by x into x minus 3. So different ways you could write your answer, right? Now, the reason why I decided to show you how you can factorize and further simplify, sometimes the question may ask you to simplify to the lowest terms, right? And that's how you continue simplifying all the way down. All right, so let's continue the discussion. We're moving on to question number 2 now. So let's make some space right here for question number 2. All right, so we gotta solve this question here. So you got an equation, so you gotta solve, make x the subject of that equation. So let's do this. So this will give us minus 15 plus 6x. So remember we are multiplying minus 3 by 5 to give us minus 15, then minus 3 by minus 2 to give us plus 6x, minus 3 by minus 2x to give us plus 6x, and you have the plus 7 equals 4x. So we're going to take our time with this. These two numbers here, your constants, can be simplified. Minus 15 plus 7 is minus 8 plus 6x equals 4x. So we're solving for x. So it means that we need to bring all our x's together on one side. So we need to eliminate this x here. So we could minus 6x here. And we need to do the same thing to maintain the equality on both sides. So this will cancel out. So we left with minus 8. And 4x minus 6x will be minus 2x. And then we proceed to divide both sides by minus 2. This will cancel out. And minus 8 divided by minus 2 is plus 4. So you end up with x equals to 4. There you go. So that is question number 2. Right, let's continue solving these problems. And we're going to erase some of these questions. Yep, let's erase here. Right, so we're going to be doing some factorization. Question number 3. Right, factorization, you are looking for all the common factors in the terms and that we can remove and take outside of the brackets. So if you look at the 24 and the 18, perhaps we can take out 6. 6 could go into these two numbers, 18 and 24. You have a square and you have a, so you can take out a, the one with the lower power, which is a, and you have b and b square, so you can take out b, again, the variable with the lower power. So you want to get back 18a square b. So 6 by 3 will give us the 18. Remember, it's a square, so a is already outside the bracket, it's factored out. So a by a will give us a square, and of course, we can leave it like that because when we multiply what is outside by what is inside, we will get back the 18 a square b. Right, so let's try it. It's a plus sign here. It's 24, so 6 by 4 will give us 24. You want to get 24a. We already have a outside. So we can now look at the next variable, b multiplied by b. that will give us the b squared. So when you multiply 6ab by this term here, that'll give us the 24ab squared. Right. So that, I think that's it. We can't go any further with that. This second one has to do with the difference of two squares. This is really 49n squared minus 1 squared, which is really the 1. Now the rule with the difference of both squares is that a squared minus b squared will be a minus b by a plus b, or you could write it as a plus b by a minus b. Right, that's just the rule. So our role here now is to see if we could rewrite this expression as the difference of two squares, which we can. It's really 7n whole square minus 1 square. So when we compare that with the general formula, this will be our a because it's a square, and this part here will be our b. So a is taking the value 7n in the formula, and b is taking the value of 1. So let's replace it here. So a is taking the value of 7n. Let's use the one below. B is taking the value of 1. So it will be 7n plus 1 by 7n minus 1. And that's how you use your, your difference of two squares. Okay, let's continue solving and clear this board again. Right, so we're on part C of the sums. You have your typical quadratic equation in part C. Right. So in that case, you have 3p squared plus p, which is plus 2p, minus 5. Okay, so what we need to do, you could do it the long way. I prefer the old-fashioned long method. You're looking at finding two numbers such that the sum is always a by c. When I say a by c, I'm talking about the standard expression for a quadratic, which is ax squared plus bx minus c. So you want two numbers whose product, when you multiply them, is a, which is 3, multiplied by c, which is minus 5, which is minus 15. And then you want those same two numbers must add up to the b here, which is 2. Right? So the sum must be b, and the product here must be a by c. Right? That must be the product, a by c. Right, so let's go hunting for these two numbers such that when we multiply them is minus 15, and when we add them it's 2. Right, so let's see, 3 multiplied by minus 5 is minus 15, minus 3 by 5 is minus 15. Well, let's start off with the product first. 15 by minus 1 is minus 15. Minus 15 by 1 is minus 15. So those are your two numbers whose product equals minus 15. Now we have to see which of them, when we add them, the sum works out to be 2. Now when you add 3 plus minus 5, you get minus 2. When you add minus 3 to 5, you get plus 2. When you add 15 to minus 1, you get minus 15. When you, sorry, not minus 15, minus 14. And when you add minus 15 to plus 1, sorry, you're going to get plus 14 here. And you're going to get minus 14 here when you add those two numbers. So the only pair that gives us the sum being plus 2 is minus 3 and minus 5. Okay, so what do we do next? Right, so we're going to replace this middle term here, the plus 2p, by minus 3p plus 5p. So let's write that. So we're gonna have 3p squared. You're replacing that 2p by minus 3p, right? Minus 3p plus 5p. Right, so what you're basically doing is just thinking of these two numbers and using the variable p alongside them to work out this step. And of course, you rewrite your minus 5, that's the rest of the problem here. So when you add these two, your sum is plus 2p. And then, of course, you go by factorization, by grouping. You factorize this. You take each pair, that's a pair, and then you take the second pair and you factorize. So if we have factorized the first pair, you're going to get 3p into p minus 1. That'll give us this expression, 3p squared minus 3p. And let's take out the 5 here into p minus 1. Now, how you know you're doing this correctly is that the terms in both brackets must be the same. And then, of course, you can further factorize this. 3p plus 5. Whatever is outside the brackets, you're going to put in one pair of brackets. And the one that's inside, you only write it once. So that'll be your answer in terms of factorization. So the last part, part D, is going to tackle this factorization. We just did it. This is where you have 4 terms. So we just tackle this by factorization by grouping. And we could probably write our answer just below it. Let's see if it'll fit. So you could take out, let's see what is common. Oh, there's nothing is common. So you need to rewrite that, which we can do here, of course, right? So let's do that. So we're going to pull a line around this, make some space right here. Right, and let's tackle that question there. Right, so you cannot factorize these using the first pair and then the second pair because you don't have any common factors here. What you need to do, you can rearrange the problem. So you could write it as 16xz minus 8wx minus 3wy plus 6yz. Now, by rearranging the terms, of course, keeping the signs in front each term, you do not change the problem. It's the same expression. You rearrange the terms so that now you can find at least one factor, maybe 2 to pull out, right? So let's see what could happen here. 16 and 8, right? So you can take out the number 8 here. And you also have the variable x common. So the factor that is being placed outside the brackets will be 8x. You want to get back 16xz. So 8 by 2 will give you 16 by the x, and you simply write back your z. So that'll be 2z. You have 8wx. So this will be minus w. And again, if you're doing it correctly, you'll get the same expression inside the next pair of brackets. So what can we take out? Right. So let's take out 3. So this will be plus 3. Right, and you could also take out a y here. So you're left with minus w or minus 1w, which is the same thing. When you multiply minus w by 3, yw, get back this. And you're left with plus 2z. Now, although the term in w is written first, the two sets of terms in both pairs of brackets, they are one and the same. Minus w plus 2z is the same as 2z minus w, right? Now, before we continue with the last line, let's see what would have happened if we had taken out minus 3. That's why I took out a plus 3y. Let's see if we had taken out minus 3y. So the first part of the problem we would have already worked out. If you are taking out minus 3y, you would left with plus w here minus 2 by z minus 3y by minus 2z will give back plus 6yz. So your terms will not be the same, and hence the reason why we took out plus 3y instead of minus 3y. So we'll put a stroke through this. This would be incorrect. So the last line we said, since these two are the same, you can write it. Let's go with the 2z minus w first. So this will equal to 2z minus w. And what we are left with, we'll have the 8x. All right, let's highlight it. You have the 8x plus 3y. That's what goes in the other pair of brackets. Nice. So that is question number 3. So I'm going to continue working. I don't want to put this video into 2 parts. I think we can continue working. Let's go to question number 4. It may be a little longer than usual, but let's continue working this out. Okay, so in question 4, you're given the width of the floor and you're given the length of the floor as well as the area. So what we need to do, we need to write an expression for the width of the garden. Right, so let's say the width of the floor is 3 meters less than its length. So let's call, let's say the length of the floor is x meters. So if it's 3 meters less, the width will be x, take away 3. Now it's always a good idea to draw a nice little diagram. So the length of the floor is x meters, we can put x here. They say the width is 3 meters less than its length, so it will be x minus 3. So we first wrote the expression for the width. Express the area of the garden in terms of x. So area is always based on a rectangle, is length by width or length by breadth. Right. Now, of course, we are assuming it's a rectangular garden as shown, right? What's the area of the garden? So you multiply length by width, or yeah, so it will be x by x minus 3. Now what did it tell us? They said the area is 40. Find the dimension of the garden. Dimension means we need to work out what is the length and what is the width. Okay, so this one, we have an expression for the area in part 2, and we are told that area is 40. And we could remove the brackets here. This will be x squared minus 3x minus 40 equal to what? To 0. So we have the quadratic formula. You could use to solve that if you wish. But I like the traditional approach as I showed you earlier. Once it can work, right? So we know A is 1, B is negative 3. Let's write it here. A is 1, B is negative 3, and C is equal to minus 40. Now, remember, we comparing this with ax squared plus bx plus c equals to 0 as the standard quadratic equation. So a would be 1, b would be negative 3, the entire expression including the sign, and c, which is the constant by itself, would be minus 40. So that's how come I got my values here. Again, we want two numbers whose sum is minus 3. So this is the sum here. The sum must equal minus 3. And whose product is a by c. This is here a multiplied by a c, which is minus 40. Right, so trial and error. Product minus 40. The two numbers that I can choose when I multiply and give me minus 40 will be minus 8 and 5. We know minus 8 by 5 would be minus 40, and minus 8 plus 5 will be minus 3. So remember how we said it? You're going to replace the middle term by those two numbers, add in your x, of course. So the equation becomes x squared minus 8x plus 5x minus 40 equal to 0. So let's solve. X can be factored out here, you'll have with x minus 8. 5 can come out here, you'll have with x minus 8 equals to what? To 0. So when you further factorize, you get x minus 8. Let's fix that, x minus 8 by x plus 5. And that will give you 0. Now, you're solving. So you're saying either, you take the first factor, either x minus 8 is equal to 0, in which case x will equal to 8, or x plus 5 is equal to 0, in which case x is equal to negative 5. Now, x is defined as the length of the card. Now, in this context, we'll have to disregard a negative value for x because x cannot be negative, right? So we will disregard this answer here. So far, based on the diagram we have above, the length x will be 8, and they say the width is 3 meters less. So the length will be 8 meters and the width will be 3 meters less, as shown here, 8 minus 3, which is 5 meters. So that's the dimension. Length equals 8 meters. The width equals 8 minus 3, 5 meters. And when I multiply them, 8 by 5 will give you the area of 40 meters square. So that'll take care of question number 4. So we are going very good indeed. We got 3 more questions. All right, let's see how we can tackle those 3 more questions. All right, so we're on question number 6. We have a pair of simultaneous equations to solve. Let's do that. X plus 5x. All right, so let's multiply this equation up here, which we'll call equation 1. Let's multiply this by 2. So this will give us 2x plus 10y equals to 18. We're going to use the elimination method. So we're going to subtract 2x minus 2x will give us 0x. 10y minus 3y will give us 10 plus 3y, which is 13y. And 18 minus 8 will give us 18 plus 8, which is 26. So we can easily solve for y by dividing both sides by 13. So here, we told that y is equal to 2. Now, once you know the value of y, you can go back to equation 1 and substitute y equal to 2 into equation 1. Now, let's solve. So if y is 2, this equation becomes x plus 5y, which is 5 by 2, equals to 9. Is that 9? Yes. So you have x plus 10 equals to 9. So we're going to subtract 10 on both sides. So you end up with x is equal to minus 1. So those are your two values. X equals to minus 1 and y equals to 2. So next question. Right, a piece of rope, 1.0, 8 meters cut into 3 pieces. The length of the first piece is x. So let's try to draw that out here. Right, so it's cut into 3 pieces. Right. Right, so the length of the first piece is x, right? That is from here to here. That's the length of the first piece. The whole rope, which is 1.08 meters, is cut into 3 pieces. The second piece is 5 centimeters shorter than the first piece. So if the first piece is x, 5 centimeters shorter will be x take away 5. That's the second piece right there. And the third piece is 3 times as long as the first piece. So it will be 3x. So you have the 3 pieces marked over there for you. Right? First, second, from here to here, right here. And of course, I have the third piece, which I'll put in green. Let's highlight it right here. And I've indicated on the diagram the 3 different expressions, x, x minus 5, and 3 times x. Write an algebraic expression, in terms of x for the length of each of the 3 pieces. So I did that. Right, so if you wish, you can simply repeat your answer. First piece is x. Second piece is x minus 5. And the third piece right then. Let's fix that. Right, the third piece is 3x. So that's the expression for each of the pieces. Write an equation for the sum of the 3 pieces. Well, we just add them. So the sum of the 3 pieces will be x. Let's write it here. X plus x minus 5 plus 3x. So that's the sum. And going into the last part of the question, hence solve the equation to find the length of each of the 3 pieces. So we know this total sum is, now it's in centimeters, the sum is given here in meters. So you cannot say that the sum of these 3 pieces, because they say they are, the first piece is x centimeters, but you have the total length as 1.08 meters. So 1.08 meters, you multiply that by 100, would be 108 centimeters, right? Because we need to keep the measurements on both sides, the dimensions consistent. So that's a catch right there. All right, so let's simplify. X plus 3x. 5x minus 5 equals 108. All right, so let's double check that. The first piece is x. Second piece is 5 centimeters shorter, so it will be x minus 5. And the third piece is 3 times as long as the first piece is 3x. So you have x plus x minus 5 plus 3x equals 108 centimeters. Simplifying, I'll give us 5x minus 5 equals 108. Of course, we're going to add 5 on both sides, so eliminate that minus 5 there. Right, so that will cancel out. So what you do there, really, you are using the additive inverse. If you have a minus sign, you change the sign. If you have a plus sign, you change the sign, right? And you just sum them. So this will be 108. Remember, you're adding 5. So this simplifies to 5x is equals to 108 plus 5. Right, so that will be 113. So x will be 113 divided by 5. And that answer is in centimeters. So let's work that. $22.6. So that's 22.6 centimeters. So that this piece here, this piece will be 22.6 centimeters. X minus 5, so you're taking away 5 from this will be 17.6 centimeters. And this last piece will be 3 times x. Let's work that on the calculator. 3 multiplied by 22.6. Right, 67.8. Right, so to make sure that you have the right answer, if you add up those 3 pieces, you should get 108 centimeters, right? So let's do that. 108 centimeters. Let's add up these three. So we're going to verify that 22.6 add 17.6 add 67.8. Right, so that's 108 centimeters as shown. So we did our calculations okay, in spite of the answers having decimal parts. Now, let's go to the last question, number 7. Again, simultaneous equation, so we could probably clear that last part there. The cost of 5 apples and 4 pears is 16, while the cost of 3 apples and 10 pears is 21. X represents the cost of an apple, right? And Y represents the cost of a pear, right? On two simultaneous equations. So if you have 5 apples and 4 pears, then the total cost of the apples, 5 apples will be 5 times X. Right? So we're tackling this first part of the equation. 5 apples and 4 pears. Total cost of the pears will be 4 times Y, because Y is the cost of 1 pear. And the answer there is 16. And we do the same thing for the second part of the problem. 3 apples and 10 pears cost 21. Okay, so what do we do? Well, I like to use the elimination method here. It's easier. So we need to, let's get the coefficient of X to be the same. It's now 3 and 5, right? So we need them to be the same. Usually you just multiply throughout the equation by the coefficient of the other one. So if it is 5 here, we could multiply this one throughout by 3, which is here. So this first equation will read 15x plus 12y equals 48. Now you want to get 15, you have a 3 here. So you multiply everything by this one here, 5. So it will give us 15x plus 50y equals 105. We're going to do some subtractions. So it's easier to put the smaller equation below in terms of the numbers. So we're going to put the 12y here, and we're going to put the 48. Now, check over this. Make sure we didn't make any errors in the multiplication. 5x by 3 is 15, 4 by 3 is 12, 16 by 3 is 48, 3 by 5 is 15, 10 by 5 is 50, 21 by 5 is 105. Okay, so it's time to subtract. So we can see how our X will be eliminated. It's the elimination method. 50 minus 12 will give us, that's a big number, 38. Right, and let's do the subtraction here. 15 is 7. All right. And this will be 9. You borrow 1 from 10, will give us 9. 57. The numbers looking a bit clumsy, but let's go over the problem. 5 apples and 4 pears is 16. X is the cost of an apple, Y is the cost of a pear. 5x plus 4y is 16. 3 apples and 10 pears is 21. Right, so the equation seems to be set up pretty okay. When you multiply this by 5, you get 105, 5 2s are 10. Right, so let's do the subtraction using the calculator just to double check these numbers. So 105 take away 48. Yet it is 57. And 50 minus 12. Well, 50 minus 12 is 38. All right, so let's divide by 38. So we're gonna run into some, see, we're gonna get some decimals to work with. So let's see. Solving for y. Y will be 57 divided by 38. Right, $1.50. So that's the cost of a pair. Right, a pair costs $1.50. Right, so we got to be careful with that 1.5 when we substitute in the solve for x. Let's go back to the first equation right here. We're going to replace y as 1.5, so you're going to get 5x plus 4 by 1.5 equals 16. Now 4 by 1.5 is 6. So 5x plus 6 equals 16. You subtract 6 on both sides to eliminate that 6. Right, so you get 5x equals 10. You divide by 5 on both sides. So that means that x will equal to 10 divided by 5 is 2. So there you go. The cost, find the cost of an apple. The cost of an apple is $2. Right, because that is the value of x here, $2. And the cost of a pear is $1.50 in this case. Okay, so this was a mouthful, I must admit, but we saw it through to the end with God's help, right? So continue to be safe. God bless until we meet again.